Assalamualaikum and very good morning to the examiners and my fellow friends. Me myself is Syamimie Azlin binti Syamimie together with my supervisor which is Dr. Siti Roshayu binti Hasan. So today I would like to present the innovation project title with project of Mush-G Compost. Without further ado, I would like to start my presentation. So firstly, what is Mush-G Compost? Okay, so basically, Mush-G Compost is the terms that come from spent mushroom substrate or also known as SMS, where it is actually a waste or residual from mushroom cultivations. Furthermore, after the cultivation cycles of mushroom, the productivity of SMS are decreases and cannot be used as cultivating medium anymore. However, it's still rich in organic matters and nutrients. The spent causes leaches and continue to compost uncontrollably if improper management. Thus, SMS can be utilized become something beneficial such as biocompost as it holds many nutrients. Furthermore, it also a good source for soil conditioner for the cultivation of vegetables, fruits, and flower. Next, the objective of this project innovation is innovate valuable products which is Mush-G Compost by using agricultural waste, and the second is to study the chemical and physical characteristics of Mush-G Compost. Okay, next is biocompost. For biocompost, the properties of biocompost were divided by two, which is physical properties and also the chemical properties. The properties of good biocompost such as pH, moisture, color, texture and odor, optimal carbon-nitrogen ratio, temperature and also the particle size. Next is scanning electron microscope or also known as SEM. SEM is used to observe quality of the compost and it provides complete information towards the sample properties. It also detects the morphology and topography of the specimen. While for product valuable, the unique of this project where the Mush-G Compost is actually agricultural waste that contain beneficial microorganisms. Furthermore, it is also easy to access where all the material used was the waste that available in our environment. Furthermore, it is also providing all the nutrients that needed by plants. And lastly, it is easy to handle because it just left for some time and let the microorganism do the works. Here is the product advantage where Mush-G Compost was containing more nutrients, more moisture, low in cost production and faster growth of plants compared to the commercial compost. Okay, next we move to commercial value of the product, where this product of Mush-G Compost was save times compared to the commercial value because it is only taking 3 weeks for them to complete the process of composting. For the price, it is also cheapest compared to the others because it only needs waste that comes from our environment such as foliage, newspaper and others. It is also effective. It is proof that the plant that we grow were grown higher compared to that plant that use commercial compost. Thus, this Mush-G Compost would be more effective. Next is approach and methods. This is the list of materials and equipment that were used in this project. For the methods, the raw material that were used in this study was SMS, carbon nitrogen sources, temperature, pH, oxygen, moisture, and particle size of raw materials. While for the compost pile preparation, there were 3 different compost piles were observed. The first pile is different in terms of sizing, while the second pile was different in terms of carbon-nitrogen ratio, and lastly were different in terms of turning of the piles. Next is layering of composting, where in this project, the layering of composting were constant variable throughout the composting process. Next, table 3.3 shows the parameters that were taken every day during evening, which is pH, temperature, moisture, and light intensity, while the table 3.4 shows the different ratio of carbon nitrogen with their weight for each carbon nitrogen. So, here is the picture of composting process. The effects of different parameters on SMS drive biocompost were the effects on different in pile sizing, carbon nitrogen ratio and also the turning frequency. For the pile sizing, the best size was 1 feet size where it is dark brown in color and more crumbled compared to the others. The bigger size in this study was 1.6 feet and this size do not show the best because the piles was too dry even the same moisture is given. Thus, microbe cannot work efficiently with dry piles. According to Amin et al. 2016, microactivity become minimum when low moisture provided. For the parameter like pH, moisture, temperature and light intensity for 1 feet size were in optimum condition. While for the effect of different ratio in carbon nitrogen is the best at 20:1. This is because the parameters like pH, moisture, temperature and light intensity were in optimum condition. Furthermore, the finished compost also was nicely crumbled and do not give bad odor compared to the others pile. Thus, carbon nitrogen ratio of 20:1 were approximately within the range of optimum ratio value that have studied. while for the effect of difference in turning frequency is 2 days of turning. This is because it gets enough aeration to the piles by increasing the porosity and also helping microorganisms activities, such as degrade the compost material and generate heat for the compost. Furthermore, oxygen was helping in decomposition of organic bacteria. For the impact, growth potential and sustainability. For the potential application on vegetables, spinach is used to plant and it started planted on 14 January and start to sprout on 16 January. Figure 4.1 were the plant on 16 January while figure 4.2 were the plant on 20 January. Table 4.1 shows the height of the plants where plants that use mush compost shows the highest. Furthermore, Table 4.2 shows the optimum parameters of the mush compost, where mush compost showed the best moisture content compared to commercial compost, which is 50 to 61%, and this range were the optimum that compost should have, while for the chemical characterization, the value of pH were slightly above between 5.5 to 8.0, and this value are very suggested by the researchers. For the physical characterization, Table 4.3 shows the differences in color, odor, and texture of the compost pile. While for the moisture content, it was observed by drying the sample for 24 hours with 105 degrees Celsius, and then it shows that mush compost get the good reading of moisture level compared to commercial compost. For the temperature, the higher temperature was 35 degrees Celsius. However, this temperature do not show the optimum temperature that's stated by most articles. The weather might be impact the temperature of the compost pile. Next is light intensity. Light intensity, it is between very low and little low. Okay, next we move to morphology characterization, where it shows the scanning electron microscopy image of commercial compost and mush compost. If we can observe, the commercial compost is more compacted and flocked between their materials, while for the mush compost are more fragmented, porous and granular in structure, and fibrous in shape. This is because the compost gets adequate moisture and aeration, thus it gives fibrous structure. Next, for sustainability, the waste to wealth were produced by innovate this mush compost. Growers' problem in handling spent mushroom substrate were solved. Furthermore, this product should be sustained because of mush compost could be produced in shorter time with great efficacy. This can be proved by the growth profile was better by using mush compost compared to commercial one. For conclusion and recommendation, for the conclusion, the experiment conducted are successful. The compost dark brown in color, and it means that the compost already mature. Aim of this study also achieved, and spinach grows healthy and faster using mush compost rather than commercial one. For the recommendation, more research regarding the chemical characterization and biocompost could be produced more precise and quality. So here is the references. Thank you.